First derivative test, mean value theorem, second derivative test, just 3 things on it. How'd the worksheet go last night? I don't think I put the key on yours. About to get fancy. Oh, I didn't make you guys do the free response, did I? You can see them all.
Which one?
No? Why not? My fingers aren't working today. Maybe it's the papers are stuck together. Did everyone get one? How did I not notice? What's going on here?
There's no way you didn't notice that. You stood right in front of me.
I did not notice. I was looking to see what if you're on your phone. What's going on?
You like it?
It's something.
Something. You're gonna make it a December tradition now. Merry Christmas.
Merry Christmas. You need to do your eyebrows.
I was thinking about it.
Yeah.
I'm gonna put ornaments in my other finals.
They'll go all out. I like it.
This cut right said I should do half on the top of that end too, but blue.
All right. That it sounded like it stressed you out a little bit when when I passed this out. It said no calculator at the top. It looks like a quiz. It looks. No, here's what I wanted to do in all honesty. I wanted to ask the questions in the exact way you'd be asked tomorrow on the quiz. So for example, number 1, find all extrema. Please only find the x values that yield the extrema. So there is a local max at x equals 4 because f prime changed from positive to negative there. Do you notice how I didn't say 4, 35? Like, you don't have a calculator. It's not going to be nice numbers. So you're just going to find the x value on that one. Make sense? And so extrema on the first line, and then the label. What do I mean by label? Well, the extrema might be x equals 4, and the label is local max or local min. Okay? And then another one. if there is another one. And then your justify was the exact thing I just said. There is a local max at x equals 4 because f prime changed from positive to negative. We practice the justifications. Next one, find the function whose derivative is. Ooh, that one's asking you to find the antiderivative. Should it have a plus c in it? The final answer? No, because they gave us a point. Can I share a common misunderstanding with students? Not in an attempt to confuse you, but in an attempt to clarify. What is c? What is the letter c in that problem? Some constant, right? X squared plus 5. 5 might be your constant. Is that c the same or different than the c in the mean value theorem? What's that c? C is an x value where on the graph where the tangent slope equals the secant slope. That's an x value on that interval. Do you understand? It's the same letter that we used, but it's a different application. Yes? Awesome. I don't know why, but that comes with it. Number 3 asks for intervals of increasing, intervals of decreasing, and extreme. Number 4, concave up, concave down, and then point or points of inflection. You'll notice I did not say just give me the x value for the point or point of inflection. That one I actually want the x and the y value. 5, I emboldened absolute. The word absolute. I only want the absolute extreme values. The highest or the lowest value. And then number 6 is an MVT. It's the real MVT. It's the mean value theorem problem. Okay, so you have this in your hands. Here's the deal. Today is recap, review. There were people gone yesterday. This is a day for you to either ask me questions about the worksheet, work on the quiz review, go over the quiz review, get caught up with calculus stuff, not other classes. But is there anything beneficial for the whole class to go over on the worksheet that you feel like you want to talk about? Were there problems you struggled with? We can kind of see if everyone struggled. Huh? 7. How did we feel about 7? And here's the deal. Today, I'm not offended if you're like, I was good on 7. I'm going to go ahead and start the quiz review. Okay? I'm not offended by that. So if it's another day and I'm like, hey, get caught up and you're working on something else, I'm teaching a new lesson, that's different. Today, it's review day. All right, so how many of you struggle with 7? Let's talk about it. Find points of inflection. All right. You can call it dy dx, doesn't matter. First times the derivative of the second plus the second times the derivative of the first is just 1. Are you all good with that? Product rule. Product rule, product rule, product rule. Step 2. Well, it's asking me for points of inflection, so I'm going to find the second derivative. Isn't the derivative of this term a product rule? And what is it? It's this. Isn't that weird? It's that plus, and then the derivative of the second term is e to the x. Do you agree with that? Yes? Well, that's not a real pretty form. Let's clean it up a bit. We have x e to the x plus 2e to the x. What's step 3 in this process? So the second derivative equal to 0. So x e to the x plus 2e to the x equals 0. I'm going to factor out an e to the x. I'm left with x plus 2. I have two factors. I'm going to set them both equal to 0. E to the x equals 0. And x plus 2 equals 0. And these are going to give me, what are they called again? Possible points of inflection. Not guaranteed. Possible. Now, does e to the x ever equal 0? You should know that, right? No. And I even heard some people come in and are like, you know what? If I ever see a problem that has e to the x's in it, I just ignore it. I skip it. That's right. I heard you. You know who you are. Hearing like a mongoose. Okay, I can hear you all the way up here. I don't know if they have good hearing or not. It sounded right. Gavin, we'll talk later. You have a lot of fish stamps this year. That surprised me. I thought you wanted to take it head on. How far did you get in this one? Oh, so you just, I thought you said you ignored it. Was that Lane? Was that Lane? Was that you? Did you do this one?
I think so.
E to the x never equals 0. Do you agree? E to the x never equals 0. What does e to the x look like? Oh, it's that guy. And it hovers above the x-axis. Never equals 0. X equals -2 is a PPI. Does the second derivative ever fail to exist? No. Let's move on to testing. F double prime, it's not really called F double prime, it's the second derivative, which is, I like it in this form. I like it in the form of e to the x times x plus 2. You're going to find out that might be nicer to test it in that form. Okay. X equals -2 is a possible point of inflection. Maybe we'll test -1. And we'll test, oops, that's not right. -3. And maybe we'll test 0. All right, let's plug it in. E to the x is always positive. So I'm only going to test it inside of here. What's -3 plus 2? Negative times a positive, negative. Plug in 0, positive. Second derivative is positive. And honestly, because of the question, I could stop at that point. Why can I stop at that point in the second derivative test? Am I asked where the function is concave up or concave down? Am I asked where f of x is concave up or concave down? No. I was only asked for find all points of inflection. Did the second derivative change sign? Yes. Point of inflection. There is I'm going to take the time to do it because I want you guys to do it right. When it says justify, which that quiz, practice quiz says to justify. Let's practice. Practice? We're talking about y has a point of inflection at 0, -2, to be determined. Because, help me justify. Who wants to make me proud? Because Madison. F double prime of x changes sign. You could say negative to positive. That'd be even better. All it has to do is change sign. Doesn't matter how. Changes sign. At y has a point of inflection at -2, something, because f double prime of x changes signs there, right? I don't know that people would do this. Another correct justification, y has a point of inflection at -2, something, because f prime of x changes from, I would not do this, I would not recommend it, but it is correct still. Changes from, what was it? Decreasing to increasing. Decreasing to increasing. Now, because it's a point of inflection, you could also say y has a point of inflection at whatever, because f of x. Oh, I was kind of, that's sloppy. I apologize. I started off calling it y, and then I called it f double prime. Technically, it's d squared y over dx squared, right? I can't type that in right now. And I called it f double prime. I apologize. It's the second derivative of y. You could write y double prime if you wanted to. Y double prime. Actually, I'm going to do that. It's bothering me. Y prime prime. And down here, y prime. Here's y changes concavity. Okay. Now, be careful. And I don't want to confuse you. I just want to be clear. Mr. Westphal, I thought you said when we did extrema, you have to use the derivative to justify whether it's a max or a min. Yes, still the case. You cannot say y changes from increasing to decreasing for a max. Okay? You have to use the derivative. Okay? But do you see how when we say y changes concavity, we are using the second derivative in our words? Do you understand the difference there? Now, you could argue when you say increasing, you're using the derivative, saying the derivative is positive. I think that's a little bit more of a stretch because you knew whether a function was increasing or decreasing back in Algebra 1. Concavity is a calculus term we just learned. Please help me. Was that clear? I'm trying to be very clear and upfront. Is that clear? Okay. The AP test graders would accept any of these three for justifying the points of inflection. All right, let's plug it back in and see what the original was. It's going to get messy. When x is -2, y is -2e to the -2, which is -2 over e squared. -2 over e squared. -2 over e squared. Make sense?
For justification, you don't want to put the exact point. We can't just say x equals -2.
It'll tell you on the quiz. If it doesn't say just give me the x value, it wants the y value as well. What else can I help you with? You want time to review? Do you want to ask questions on the worksheet? Who votes for work time on the I said worksheet. I meant quiz review. Who wants time to work on the quiz review? All right, awesome. I'm here to help.